So today we are going to be solving an interesting exponential equation. It has been given that if 2 to the power x minus 3 to the power x equals to square root of 6 to the power x minus 9 to the power x, then find the value of x in the real plane that will satisfy this particular equation. So this is Anmol, and now let us see the solution. How can we solve this problem? Okay, now let us start with the solution. So the first thing we can notice over here is the square root present on the right hand side. And this is the thing that is making this equation looking complex. So to get rid of this thing, first of all, I will square both of the side in this equation. So the first step in our solution is squaring both of the side. Therefore, 2 to the power x minus 3 to the power x, the complete square, equals to square root of 6 to the power x minus 9 to the power x, the complete square. Now on the right hand side, the thing is very simple. The square root and the square will get cancelled out, and the final thing remaining would be 6 to the power x minus 9 to the power x. Okay. Now on the left hand side, we have to use the algebraic identity of a minus b, the complete square, and that would be a square plus b square minus 2 times the product of a, b. So using this identity on the left hand side will give me the result as 2 to the power 2 times x plus 3 to the power 2 times x minus 2 times the product of 2 to the power x and 3 to the power x. So let me just make this thing clear over here. So 2 times the product of 2 to the power x multiplied with 3 to the power x equals to 6 to the power x minus 9 to the power x. Okay. Now this thing can be simplified over here. Remember the exponential rule, that is a to the power m multiplied with b to the power m can be written as a into b, the complete power m. So the same thing is happening over here. The bases are different but still the power is same. Therefore this thing can be written as 2 into 3, the complete power x, and this thing will simply means 2 into 3, 6 to the power x. So 2 times 6 to the power x is the final thing remaining over here. Now we can see that in this particular equation we have some like terms. So one we can see is 6 to the power x present on both of the side, and the other is 3 to the power 2 times x, and that is present only one. Where is the second one? So the second one is over here, 9 to the power x. So remember that 9 is ultimately 3 square, so I can write 3 to the power 2 and the complete power x. And again the exponential rule, that is a to the power m, the complete power n is a to the power m times n. So according to that particular rule, 3 to the power 2 and to the power x will turn out to be 3 to the power 2 times x. Okay. So now we have these two like terms over here and these two like terms over here. So what I will do is I will simply shift this term on that side and this particular one on this particular side. So the final thing I will have is 2 to the power 2 times x plus now 3 to the power 2 times x, and this negative will come on the other side, so it will become positive. Hence I will have 2 times 3 to the power 2 times x equals to 6 to the power x as it is, and this negative will go over here, so become positive. So finally I will have 3 times 6 to the power x. Okay. Now what I will do in the next step is I will simply divide both of the side with 6 to the power x. So on the left hand side we will have 2 to the power 2 times x divided by 6 to the power x plus 2 times 3 to the power 2 times x divided by 6 to the power x equals to 3 times 6 to the power x divided by 6 to the power x. So on the right hand side we can see only 3 will remain, as 6 to the power x can be simply cancelled out. Okay, now let us simplify the left hand side. So on the left hand side, first of all, recall this exponential rule that we have written over here. A to the power m into b to the power m can be written as a into b, the complete power m. So if the exponential is in this particular form, it can be written like this way, and if the exponential is in this particular form, it can be broken down to this one. So the same thing we will do with 6 to the power x. We all know that 6 can be written as 2 into 3 and the complete power x, and according to that exponential rule, 2 into 3 the complete power x can be written as 2 to the power x into 3 to the power x. Okay, so in both of the denominator, the 6 to the power x will turn out to be like this way. So the numerator as it is, first of all, divided by, now instead of 6 to the power x, I will write 2 to the power x into 3 to the power x, and this thing equals to 3. Now we know this particular exponential rule, that is a to the power m divided by a to the power n equals to a to the power m minus n. So the same rule can be utilized over here. We have 2 to the power 2x divided by 2 to the power x. The bases are same and the powers are different. And the similar pattern is present in this particular term. We have 3 to the power 2x divided by 3 to the power x. And the condition is fulfilled very nicely. The bases are same and the powers are different. So according to this exponential rule, the thing will turn out to be 2 to the power 2x minus x. So that will turn out to be simply 2 to the power x, and 3 to the power x in the denominator as it is, because we have not utilized that one. Plus, now over here, First of all, this 2 as it is multiplied with now 3 to the power 2x divided by 3 to the power x will give me 3 to the power 2x minus x, and that is going to be simply 3 to the power x, okay, divided by, and this 2 to the power x in the denominator as it is, and this thing equals to 3. Now remember one more exponential rule, that is a to the power m divided by b to the power m can be written as a upon b the complete power m. So the same thing is over here. The bases are different, 2 and 3, but the powers are same, and over here also the bases are different but the power is same. So this whole fraction can be written like 2 upon 3 the complete power x plus now this 2 as it is, and the remaining fraction can be written as 3 upon 2 the complete power x, and this thing equals to 3. Now to simplify this equation further, we have to use the substitution method. So what I will do is I will simply take 2 upon 3 the complete power x as another variable a. So if this thing has been taken as a, and if I reciprocal both of the side, what I will get is 3 upon 2 the complete power x equals to 1 upon a, okay. So we can see that when we let 2 upon 3 to the power x equals to a, we also get the value of 3 upon 2 to the power x, okay. So now both of these terms can be just represented in terms of a. So when we do so, this equation will look like a plus 2 times 1 upon a equals to 3, okay. So now we have this particular equation, and this can be simplified very nicely. All we need to do is, first of all, we need to multiply a on both of the side. Therefore I will get a square plus 2 equals to 3 times a. I will adjust the terms in this particular equation in order to get a square minus 3 times a plus 2 equals to 0. So here we have a quadratic equation. You can use the quadratic formula to solve this thing, or else you can use the factorization method. So I would like to go with the factorization method because it is very simple over here. All we need to do is we need to break down negative 3 times a as negative a negative 2 times a and plus 2 as it is. You can see that we simply splitted negative 3 times a as negative a negative 2 times a. So now what I will do is, from the first two terms I will take a common, so inside the bracket a minus 1. From the other two terms I will take negative 2 common, so inside the bracket a minus 1 equals to 0. Now from this whole equation I can take a minus 1 common, so inside the bracket a minus 2, and this thing equals to 0. So now we have this particular equation, and it is saying the value of product of this particular term is equals to 0. So this simply means either this bracket has a value equals to 0 or either this bracket has a value equals to 0. So when we equate a minus 1 equals to 0, we get the value of a equals to 1. And when we equate a minus 2 equals to 0, we get the value of a equals to 2. So here we have got the values of a that will satisfy this particular equation, and that is ultimately this particular equation, okay. Now recall that we have substituted 2 upon 3 to the power x equals to a. So now the values of a that we have just obtained, we have to put it over here. So we can see there are two values of a, so there will be cases over here. So we have taken 2 upon 3 to the power x equals to a, and now we have the values of a equals to 1 comma 2. So let me write this equation two times, one time equating this equation with 1 and the second time equating the same equation but with 2, okay. Now look carefully at the first equation. On the left hand side we have 2 upon 3 to the power x equals to 1. Now we know this particular fact that anything raised to 0 is equals to 1. And the other possibilities in which we will get 1 is 1 to the power anything. So we can see that this particular fraction over here is not equals to 1. This means we have to take this particular case where this is any number, okay, and this power should be 0. So in that kind of situation only we will get the result as equals to 1, okay. Therefore the value of x that will satisfy this above equation is x equals to 0, okay. So here we have got the first value of x. Now let us see the second equation, in which we have 2 upon 3 to the power x equals to 2. And to simplify this equation, we have to simply take the natural log on both of the side. Therefore natural log of 2 upon 3, the complete power x equals to natural log of 2. Now we know this logarithmic rule, that is natural log of a to the power m is m times the natural log of a. So we can utilize this rule on the left hand side because we have natural log of 2 upon 3 to the power x. So this thing will turn out to be x times the natural log of 2 upon 3, and this thing equals to natural log of 2. Now in order to get the value of x, I will simply divide both of the side with natural log of 2 upon 3. Therefore the value of x will turn out to be natural log of 2 divided by natural log of 2 upon 3. And boom, here we get the second value of x. So the values of x that will satisfy this particular exponential equation is x equals to 0, or else natural log of 2 divided by natural log of 2 upon 3. And this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.